and welcome to our first video on Unit 8, Waves and Optics.
Today we're talking about waves and optics. Woohoo!
Today we will be learning about wavelengths. This is an example of one. This line at the center is called the equilibrium. From the equilibrium to the top of the crest is called an amplitude. And the very top of the wave is called a crest. The bottom is called a trough. The entire wavelength is considered from the center of this to the center of this. This is considered a wavelength. A transverse light wave is particles that vibrate at the same angles to the direction of the motion. This would be a light, and this is an example of a transverse wave. The next wave we will be talking about is longitudinal wave, and this is a picture of one. So these are usually sound waves. In a longitudinal wave, particles vibrate parallel to the direction of motion. In this, you can see where they're closer together, this is called compressions, and where they're farther apart, this is called rarefactions.
Alright, this is how you make a Nutella sandwich. So you get some bread, have your Nutella, you're going to open it, and you're going to take your knife and replace it with a spoon. You're going to take a big scoop of Nutella, and you're going to eat it. Very good. Don't worry about the bread. Just eat the Nutella.
For Unit 8, these are the equations. The first is the wave equation. It's velocity equals frequency times wavelength. Next is index of refraction. It is n equals c, which is the speed of light, over v, velocity. Next is Snell's law, which is n1 times sine of theta 1, which is an angle, equals n2 times sine of theta 2. The last is critical angle formula, which is sine of the critical angle equals n2 over n1.
Also, there is lens or mirror equation, which is 1 over di plus 1 over do equals 1 over f. Magnification, m equals di over negative do, which equals hi over ho. And focal length, which is f equals r over 2.
These are the rest of the formulas for Unit 8. The first is angle to max or minimum, which has two. The first is d sine theta equals m times wavelength. And the second is d sine theta equals m plus 1/2, all times wavelength. Next we have perpendicular distance to max or minimum. X max is equal to m times wavelength times L over distance. X minimum is m plus 1/2 times wavelength times length over distance. Finally, we have the Doppler effect, which is the frequency heard by observer, or F2, equals the frequency of the source, F1, times velocity of the sound in the medium plus the velocity of the object, all over velocity of the sound in the medium plus or minus the velocity of the source.
The rest of the formulas are thin film, 2nt equals m wavelength. The next one is 2nt equals m plus 1/2 times wavelength. Pipe organs, one end open is L equals wavelength over 4. Both ends open equals wavelength over 2. The final formula is beat frequency, which is FB equals the absolute value of F2 minus F1.
So this is an example of a free response question on Unit 8. So this will be covering converging and diverging lenses. First, a thin double convex lens of focal length f equals 15 centimeters is located at the origin of the x-axis as shown above. An object of height 8 centimeters is placed 45 centimeters to the left of the lens. The first question, or letter A, is on the figure below, draw a ray diagram to show the formation of the image by the limbs. Clearly show principal rays. So, when drawing this image, you first take note that this is a converging lens. So that means the rays on this side will come together. So, knowing this is the object, mark that as your object. There are going to be three principal light rays when constructing this. So the first goes from the object towards the lens parallel. Then it bounces off towards the F. So it'll go like this. The next will go from the object towards the mirror lens on line with the F, which is the focal, and it bounces off parallel. So it'll go like this. And then bounce off parallel. The third is from the object towards the mirror lens on line with C, and it bounces, or it goes straight through. And this will go like this, straight through the center. Where the three lines meet up at this point is where the image will be. So the image on this is an inverse, smaller image. So it's going to be smaller and inverse, but it will be real since it is a lens and not a mirror.
So for letter B, it says calculate, do not measure each of the following. The position of the image formed by the lens is di, that is what you're trying to find. So we're going to use this formula, which is 1 over do plus 1 over di, what you're trying to find, equals 1 over f, which is the focal length. So you do 1 over 45 plus 1 over di equals 1 over 15. Then solve the equation for di, which is di equals 22.5 centimeters. And number 2 on B is the size of the image formed by the lens, which is hi. And to find hi, you use the formula m equals hi, what you're trying to find, over ho equals di, which is what we just found, over do. So hi over 8 equals negative 22.5, which is what we just found, over 45. And you solve that equation for hi, and hi equals negative 4 centimeters.
So the last part of this free response is part C. Describe briefly what would happen to the image formed by the lens if the top half of the lens were blocked so that no light could pass through. So if you look at this image, it's basically saying that if only the top half of the lens is blocked, what would happen? So the rays would all still cross, despite only half the lens showing. So the image would still be formed at the same point, and it would still be smaller, inverse, and real. But what would happen is because less light went through the lens, it would be the same image, but just less bright. Hello, and welcome to our second snack break of this video. So today I have two different types of pickles. On the left, we have the Russian pickles. On the right, we have just the normal dill pickles. I will be tasting each one and rating, telling you which one you should buy. First, we're going to try this one. Standard pickle has a little bit of sweetness with a little bit of dill sour. I would rate it a 4 out of 5. Would recommend. Second, we have the Russian pickle. I've never tried this, so it's going to be interesting. Would not recommend. Too spicy, and pickles should not be spicy. I'm going to rate that a 1 out of 5. This is another example of a possible free response on your test. The question says, The figure above on the left shows a uniformly thick rope hanging vertically from an oscillator that is turned off. When the oscillator is on and set at a certain frequency, the rope forms the standing wave shown above on the right. P and Q are 2 points on the rope. Part A, it says, the tension at point B is greater than the tension at point Q. Briefly explain why. So for this, you would just give a little brief explanation. And for the answer for this is P has more mass below it, pulling it down. So this will make the tension greater. So F of T is equal to F of G. And F of G is equal to M times G, gravity being negative 9.8. So the greater the mass of the string or the point P or Q, the greater the force of gravity will be on the rope, therefore making a greater tension. This explains why point P would have a greater tension, because below it there is more mass, causing a greater mass to be put into this formula. For part B, it says, a student hypothesizes that increasing the tension in a rope increases the speed at which waves travel along the rope. In a clear, coherent, paragraph-length response that may also contain figures and/or equations, explain why the standing wave shown above supports the student's hypothesis. So for this type of question on a test, you would give a brief topic sentence and then not bullet points, but just like brief explanations of how you would solve it, the reasons behind the way you solve it, and your conclusion. So, and you can also look at the top. It usually will say like how many points the question is worth. Say it's worth 8 points. You'll want to do about 8 sentences. So the answer for this one is because the wavelength is longer near the top, and the frequency is the same all the way through, which is determined by the source, which it says up here, a set certain frequency. So the frequency is all the same. So velocity equals frequency times wavelength. So since the tension is greater at the top, this will cause the speed at which the waves travel, speed being the velocity, to be greater since the frequency is the same, if the wavelength goes up, then the velocity will go up as well. Since waves interact with each other in a completely different way than particles, they can pass right through each other and around barriers. Such behavior as interference and diffraction are possible. Since waves can be in the same place at the same time, they add up algebraically. In this example, this is a constructive interference. So the two waves are going the same part at the same time, so when they add up, they form a larger wave with a greater amplitude. A destructive interference is when they're out of phase, and so they cancel each other out, causing no wave at all, as seen here. Diffraction. Light waves form a diffraction pattern by passing around an obstacle or bending through a slit and interfering with each other. Light waves with the same wavelength pass through two slits, interfere with each other to produce light and dark interference patterns, also known as bright and dark fringes. As seen on the board below, this is a two-slit interference, and when the wavelengths come through, they form a diffraction pattern from interfering with each other. So in double-slit interference, the position of a bright fringe requires d sine theta equals m times wavelength, and the m is equal to either 0, 1, or 2, because these are going to all be a whole number of 1 or 2, the light fringes. But whereas the position of dark fringes requires d sine theta equals m plus 1/2 times wavelength. So these are going to be more like m over 2 or m over 3 or m over 4.
Thanks for watching.